Good afternoon, everyone. Welcome to the online seminars in Psycholinguistics. I am Maio Simota, and together with Professor Pamela Toassi, I would like to thank you all for being with us today. These seminars are organized by LabLing, the Language and Cognitive Processes Laboratory, coordinated by me, and affiliated with the graduate program in English and the graduate program in linguistics at the Federal University of Santa Catarina. And also by Plibimult, the bilingual and multilingual language processing research group, coordinated by Professor Pamela Toassi and affiliated with the graduate program in translation studies at the Federal University of Ceará. Today, we have the honor to welcome Professor Gareth Carrol from the University of Birmingham in the UK. And to introduce him, I will invite my dear PhD student, Daniele Visentiner, who had the pleasure to spend some time with Professor Gareth Carrol in his lab at Birmingham on a grant from CAPES last year. Before handing over to Dani, I'd like to thank you, Professor Carrol, for readily accepting the invitation to give us a talk today. Dani, over to you.
So good afternoon, everybody. It's a great honor for me to welcome Professor Gareth Carrol to the online seminars in psycholinguistics. Professor Gareth Carrol is a senior lecturer in psycholinguistics at the University of Birmingham, UK. His research looks at how language users understand idioms and other types of figurative phrase, such as conventional metaphors. This work has focused on the factors that influence processing and comprehension in native and non-native speakers, including aspects such as familiarity, transparency, and context. He is also interested in formulaic language more generally and have conducted several studies to explore the processing of a range of formulaic phrases, such as collocations and binomials, where word choice is restricted or highly conventionalized. His work uses experimental techniques such as eye tracking, reaction times, and offline techniques, rating and speaker judgments to build a detailed picture of how language users process language at the multiword level. So throughout Professor Gareth Carrol's talk, you can post your questions and comments on the chat, and I'll pass them on to him. All right. So Professor Carrol, thank you very much again for accepting our invitation to give us a talk. Okay, so it's over to you now.
Fantastic, thank you. Let me just start sharing my screen. So hopefully you can see my slides now. Are they showing okay, Dani?
Okay, yep.
Wow, excellent. Well, firstly, thank you very much for the invitation to talk to you today. I'm very pleased to be talking about research at the moment and to be able to share some of the work I've done with you all. Thanks to Dani for the very kind introduction. I hosted Dani for several months in Birmingham, and she's doing some really interesting work that's very relevant to the things I'm going to talk to you about today. As we've already heard, my work looks at figurative language and formulaic language, and it's the second of those that I'm going to concentrate on today. And I'm going to think about this from the point of view of both L1, so people speaking in their first language, and L2, people operating in a second language. And I'm going to present some evidence to you from a range of studies about how people learn formulaic language, how they use formulaic language, and how bilingual speakers, how the two languages interact in bilingual speakers. A few things I want to cover today. First of all, I am going to think a little bit about what formulaic language is, just to make sure we're all comfortable before we begin. Then we're going to think about three main questions. How do first and second language users process formulaic language? And when I talk about processing, it's mainly from the point of view of comprehension. So how do people recognize and understand formulaic combinations? Secondly, how do L1 and L2 interact during processing? So when people process language in their L2, how does their first language have an influence? And thirdly, how do people learn new formulaic sequences? So, if we encounter new combinations of words, how quickly do people start to pick these up? In other words, how quickly do things become formulaic for any given speaker? So we'll start with this question: what is formulaic language? And I guess the sort of easy way I always think about this is to contrast the very traditional, almost Chomskyan way of thinking about language as being made up of separate systems of words and rules. So we have a lexicon, we have a set of words, and then we have an implicit set of rules that tell us how we can combine those words into larger units. The problem we have is that sometimes, in fact very often, the way that words go together is based on a lot of other restrictions. It's not just grammar that tells us how to combine words. And some straightforward examples of this in English is that we, as in native speakers, would say strong coffee. We wouldn't describe coffee as powerful necessarily, even though there's nothing telling us that we can't. It just doesn't quite sound right, and native speakers wouldn't use this adjective. Similarly, if you are speaking about idioms and you in English use the phrase spill the beans to say that you've kind of revealed a secret, this is meaningful, but you can't change this, you can't spill anything else. You can't spill the peas, you can't spill the rice, you can't spill the chips or anything else. And again, another example, in English, we would tend to talk about salt and pepper, two things that go together in English, but we would never or very rarely say pepper and salt. And there's sort of an implicit order to these two words. And these are all examples of what we call formulaic language. And they're restricted in some way. So the restrictions we're talking about can be for a range of reasons. It can be conceptual. So strong coffee works in some ways. A good example would be heavy rain. So we talk about when it's raining, there's lots of rain as it being heavy rain, and you can understand sort of conceptually why rain bashing down might be considered to be heavy. So there might be sort of conceptual reasons why certain word combinations go together. Very often this is cultural, and certainly in the case of idioms, there are cultural and historical reasons why certain phrases are the way they are. Very often there's other linguistic factors, so phonological things. In binomials especially, we often find things like stress patterns or word length determining some of the order here. But actually, all of these factors aside, the main factor really does seem to be convention. Very often these combinations of words are simply repeated in the language so often that become highly conventionalized, highly sort of fixed, and all speakers agree that those are how we combine words, really. So when we talk about formulaic language, we're talking about a vast set of conventionalized multi-word expressions. And this is a really important point. By definition, formulaic language is multi-word. It consists of more than one word. And we could define this according to factors like frequency and conventionality. So if something is very, very frequent, then this is how it becomes a conventional way of speaking. We could think about it in terms of how fixed or how flexible a certain phrase is. So as I've said, with idioms, they are a very fixed combination of words. You can't spill the something else, it has to be spill the beans. We could define them according to semantic factors. So some of the examples today that I'm going to talk about, there's a degree of what I would call non-transparency in terms of the meaning. In other words, you can't always work out the meaning of a phrase just by breaking it down into its component words. And another factor that maybe is not talked about a lot in formulaic language, and I'm not going to say much about today, is things like cultural relevance. So when we talk about something being conventional, this means it sort of culturally is accepted, it's culturally sort of shared as an idea or as a way of expressing things. So lots of different variables that come into play when we're defining formulaic language. Just to give us some clear examples of the kinds of formulaic language I'll be talking about today. Collocations are often defined as conventional word partners, and these can be adjective nouns, so some examples I've already mentioned. strong coffee, big surprise, heavy rain, these sorts of examples. There's nothing non-transparent here. They mean literally what they mean, but they're very sort of fixed ways of combining these words. So strong coffee rather than powerful coffee, for example. They can also be verb-noun combinations. So we make decisions in English, we pay attention, we save money, things catch fire. And again, these are relatively literal, but they're quite conventionalized in the way we combine verbs and certain nouns here. The other type of formulaic phrase I'm going to think about is idioms. And idioms are generally described as being semantically non-decomposable. And these are genuinely the cases where you can't understand the meaning of the whole phrase simply by breaking it down into its component words. The classic example is kick the bucket. And you may or may not know this phrase, but in English, if you kick the bucket, idiomatically you die. Okay, and it's a very sort of casual way of saying that someone has died. But the point is, it doesn't involve kicking, it doesn't involve buckets. So it's impossible to understand what it means by breaking it down, by decomposing it. And that's what we mean by this non-decomposable. The point is that it's sometimes quite hard to draw a distinction here. So all of these examples using the word break, some of them towards the left are very literal. Break a window is literally breaking a window. If you break a promise, well, that's a bit more abstract. If you break news to someone, you sort of deliver news to someone, that's a bit more abstract as well. And then we have a very idiomatic use, break the ice, which means to sort of say the first thing in a conversation or sort of make the first move, socially speaking. And we can see that these very much exist on a kind of continuum of meaning from quite literal to quite idiomatic. So I'm going to talk about them as if they're different groups of formulaic language, but the reality is it's hard to draw sort of very clear lines here. Other examples are binomials, and so these are fixed combinations of words X and Y with a highly conventionalized order, so things like king and queen, salt and pepper, ladies and gentlemen, so on. And there's lots of examples in English like this, and the point is it would be very, very unlikely to hear these the other way around. This second set, actually, it's almost impossible to put them the other way around because they are also quite idiomatic. So these are things almost sort of idioms in English, but things that happen to have the form of binomials as well. So again, we're sort of blurring the lines here in some cases. Other forms just to mention, I'm not going to say too much about, but what we call phatic expressions, which are sort of social expressions. So when you meet someone, you say, how do you do? Or how are you? Or how's it going? Or something like this. What are called lexical bundles, which are just combinations of words that happen to occur very often in a language. If we use a corpus, we'll find that the 4-word combination in the middle of just happens to be quite frequent in English. What are called phrasal verbs, which are combinations of phrase plus preposition, where the preposition is sort of reduced in terms of its meaning. So you can run up a bill, for example. You can cause lots of money to be spent. You can go over your exam paper, something like that. You can look at it very carefully. So they're verbs, but with a preposition involved as well. And then lots of other examples, proverbs, catchphrases, cliches, even things like song lyrics, or if you learn or you overlearn sort of sentences or lines in a play, all of these become part of our sort of formulaic vocabulary in some way. But the ones I'm going to focus on, collocations, idioms, and binomials, are the ones we really need to understand. So that's our sort of first question. What is formulaic language? And hopefully we've got a fairly good idea of that to start with. Next question I want to think about is this. It's about processing. It's about making sense of these formulaic phrases. And I'm going to start by asking about first language speakers. So how do native speakers make sense of formulaic phrases? And then I'm going to think about how this works in people's second language as well. I just want to introduce you to a paper that came out this year. So this is a paper I wrote with Cathy Conklin, who's also here in the UK. It's actually a study that I started doing probably 4 or 5 years ago, and it was the last study as part of my PhD, and it took us a while to get round to finalising the data and publishing it. But what we aim to do in this is to directly compare formulaic phrases and to see how people process and understand idioms compared to binomials, compared to collocations. And what we did is we selected our items. We selected common English idioms, common English binomials, and common collocations, and then we created control phrases. And I'm sure all of you as psycholinguists know this is a very common way of designing our studies. We take something and then we compare it to a control or a baseline or what have you. So you'll see from this table what we've done is create two types of control for each of our formulaic phrases. So for an idiom like spill the beans, we created a control phrase where we changed the first verb, and we created a second control phrase where we changed the noun. So spill the beans becomes drop the beans, becomes spill the chips. And the question is whether or not people show any difference in how they process idioms compared to these control phrases, which are entirely literal. Same with binomials. We took a phrase like king and queen, which is a sort of a very common phrase in English, but one which always appears in that same order. We changed the first noun in our control phrase 1. We changed the second noun in the control phrase 2. And the same for our collocations. These were all adjective-noun combinations, and we changed the adjective in one case and the noun in another. And abject poverty, I think, is it's not a common phrase in English, but as a collocation, abject very often goes with a quite restricted set of words. So you would talk about something like abject poverty or abject misery or kind of words like this. They tend to be very negative, but a very restricted set of words that can follow this particular adjective. And if you're interested, I've put the reference for the paper on this, and I'll put all the references at the end if people want to sort of follow any of these up. I'm going to talk a little bit about eye tracking, because we used eye tracking to look at reading times in this particular study. And really all we did is ask people to read each of these phrases as part of a sentence and work out how long it took them to do so as a measure of processing. And I'm told that eye tracking is becoming quite common and quite popular in Brazil now. I'm just going to, it's not going forward in my slides for some reason. There we go, apologies. So what I've done is just prepare a short video. I'm hoping this will work. I'm hoping that at the moment you can see a green dot sort of flying across the screen. And what this is a video of eye tracking in real time. So this would be someone reading this particular passage, and the green dot represents what their eye is looking at any given point. If you can't see that, apologies, but you'll just have to take my word for it. But what we get from this is a clear idea of how long people spend on different words, where they go to in the text. So it could be that you read a word and then have to go backward and reread certain sections and so on. And we get data at the end of it that looks a little bit like this. It looks quite messy, but this is the data from the whole trial. So the sort of 30 seconds to a minute that it took a person to read this paragraph, these are all the times they fixated on the words whilst they were reading. And each of the circles you can see is what's called a fixation, a point in time where the eye is still. And when the eye is still, it is processing the linguistic information. And the yellow lines are actually arrows, and they show you where the person went to next. So did they jump forward? Did they jump back? Did they skip over a word? And so on. And what we're aiming to do is build up an idea of which words people spend longer on. And we're assuming that longer reading is a reflection of more difficult processing. So if you spend longer on one word than another, it could be that it's lower frequency. It could be that it's harder to make sense of in the particular context. It could be that it's particularly unexpected or so on. What we did is we took all of the items that we've created, so our idioms, our collocations, and our binomials, and we created neutral sentences to put them in. When I say neutral, what I mean is things where we're not trying to give a particularly strong hint as to what the context is trying to say, or to try and make people predict the formulaic phrase in any way. So we would have a sentence that started like this: it was hard not to. Sorry, I've missed out the two there. It was hard not to then either spill the beans, drop the beans, or spill the chips. And then each sentence continued in a way that meant it was sort of logical in of itself. So it was hard not to spill the beans when I heard such juicy gossip. So spill the beans meaning reveal a secret in this context. Then it was hard not to drop the beans when I burned my hand on the pan. And it was hard not to spill the chips when I stumbled over the step, or something like this. So we have three examples here where the whole sentence makes sense. It's perfectly grammatical, but in one case we have an idiom, we have a formulaic phrase, and in two cases we have a control literal phrase. In terms of the eye tracking, we're interested in two things. We're interested in the amount of time people spend on this whole phrase, and we're looking at two particular measures. One that's called first pass reading time, and that's a measure of how long people spend reading this phrase the first time they encounter it, before they go on to read the rest of the sentence or before they go back to reread anything. And the second, total reading time, includes firstly that first time that we're already measuring, but also any rereading. So if people get to the end of the sentence and then come back and reread, spill the beans, then that counts as part of the total reading time. So we have what's called an early measure in first pass reading time and a later measure in terms of the total reading time. We also looked as well at the reading times and patterns for the final word, because this is the bit that we're sort of expecting to be highly predictable. If you're reading an idiom and it makes you immediately think of the correct final word, then it's that final word that's going to show us the most obvious effect. So we also looked at the final word in order to see reading times for that word, but also how likely people were to skip that word entirely. So if something's very predictable, if you can process it through the paraphobia, the kind of corner of your eye, then often we see that people skip over words entirely. So do we see greater likelihood of this happening for formulaic phrases compared to our control phrases? I'm just going to talk you through some of the results here. And what we have in each of these figures is the idioms on the left-hand side, the binomials in the middle, and the collocations on the right. And in each case, for the set of three, we have the formulaic version, then the control 1 and the control 2. And hopefully we can immediately see a sort of a fairly straightforward pattern in terms of this first pass reading. So that the time spent reading the whole phrase the first time it was encountered. We see an overall advantage for all of our formulaic phrases compared to the control. So the blue bar in each case is significantly shorter than either the orange or the grey one, and this is a significant difference. And this is showing us that people read these formulaic phrases more quickly. They're more predictable, they're more familiar, and this is being reflected in shorter reading and therefore easier recognition. Same is true for our second measure, our total reading time. So one way to think about the two measures we've got here is that early reading times, first pass reading time, is about recognizing form. It's about processing the lexical form that people are seeing. Total reading time is often thought of as how long it takes to also integrate the meaning of what people are seeing. So we're seeing this advantage in terms of immediately recognizing the phrase, and we're seeing a very similar pattern in terms of how people are then making sense of these phrases. So again, our blue bars are shorter in all three cases, showing us that formulaic phrases are understood more easily than control 1 and control phrases. And this is, if anything, a clearer pattern. And the third chart I'm going to show you, same principle in terms of the idioms, binomials and collocations, but this time we're interested in how likely people are to skip the final word entirely. And this time, again, we can see for the binomials in the middle, the collocations on the right, there is a small advantage for the blue bars, but actually this isn't significant in this case. But what is very marked is the idioms. They're the ones that are driving this sort of overall picture. And we can see that for idioms, actually about 30% of the time, idioms are so predictable that people skip the last word entirely. And this is more than double the rate for our control items. So a pretty clear picture to start with. In your first language, formulaic language is processed more quickly than non-formulaic language. And this is a finding that we see throughout the literature. And it's often taken as evidence for frequency effects at the phrase level. We know that frequency matters in how we process language. We know this is well established for words. And there's now increasing evidence like this, that phrase level frequency has a real impact on processing. The interesting thing is, once we account for things like frequency and predictability, lots of this advantage disappears. So this shows us that it's primarily being driven by how frequent or how familiar these kind of phrases are. And another thing that people have often claimed based on this is that this is sort of tentative evidence for formulaic phrases having their own representation in the mental lexicon. So as well as storing words in our brains, in our minds, we also store these kind of phrases and these kinds of word combinations. And I'm going to say a bit more about that particular claim towards the end of my talk. It's really important to point out, though, that this really isn't the whole story. So frequency is really important here. When we account for frequency, we do take away much of this advantage. But actually, lots of other variables are important. And this is where we can start to subdivide our formulaic types, because different variables are important for different types of formulaic phrase. So for idioms, it's not just frequency, but also individual familiarity. So whether people personally know these idioms or not is more important in some ways. But also some of the other factors I've already mentioned. So decomposability, how much you have to, or how much you can break an idiom down. This actually makes a big difference in terms of how people process idioms. And it seems to interact with familiarity quite often. Equally, whether or not an idiom can be understood plausibly. I've mentioned kick the bucket, meaning die, but you can literally kick the bucket with no problems. That's something that could literally be true. And what we find is that when idioms can be interpreted literally, this actually interferes with the figurative meaning, because the two are competing. So lots of things come into play here for idioms as well as frequency. For binomials, semantics is really important. Binomials are very often a semantic associate, so king and queen, salt and pepper. These are words that are semantically linked in the first place. So that the strength of semantic association is important, but so is the ratio. And what I mean by that is how often a phrase appears in its forward form compared to its backward form. So something like tea and coffee. Tea very often appears first, many more times than if you ever saw coffee and tea first. So how often, how strong that sort of ratio is really important. And when it comes to collocations, yes, it's about predictability and frequency, but actually more important is what's called mutual information, which is a corpus measure. It's something we can extract from a corpus, and it tells us how much two words are likely to co-occur. And this is an interesting finding that also cropped up in this paper that I mentioned, the Ellis et al. Paper. They found that when it comes to processing collocations and formulaic phrases, frequency seems to be quite important for non-native speakers. For native speakers, they seem much more sensitive to mutual information, which, if anything, is a more sensitive measure. It's a more detailed picture of how language and words go together. So it's more than frequency that we're talking about here, and I think this is an interesting, important point to make. So how do first language users process formulaic language? Well, we've seen there's this formulaic advantage. The question is, how does this translate into second language? So if you are a second language speaker, do we see similar effects when people process formulaic phrases? I'm just going to talk about another task I did first. So this is a paper from about 6 years ago, and this is one of the first studies I did to investigate this question. And what we did is we prepared a primed lexical decision task. And again, I'm assuming that many of you will be familiar with this as an approach, but the idea is very simple. In a lexical decision task, you show someone a word, and it's either a real word or it's something we've made up. And you ask them to decide if it's real as quickly as possible. And the idea is that for real words, you say yes, and the speed with which you say yes reflects properties like frequency or again, ease of processing. So we did this by priming people with fragments of idioms. We gave them the first part of an idiom, and then we showed them either the final word or a control word. So we'd use an idiom like on the edge of your. And in English, if you say on the edge of your seat, this is an idiom, and it means to be excited. So if you're on the edge of your seat, hopefully you can see the imagery here. You're quite excited. You're sitting forward, so you're literally on the edge of your seat. And this is a common idiom. I think most native speakers would know this phrase. But we compared this to things like on the edge of your plate. And again, this is a straightforward sentence, grammatically perfectly acceptable, but certainly not an idiom. So this is our comparison of response times when they see this word. How quickly do they say, yes, this is a real English word in each condition? And if we're seeing an advantage for the idioms, then again, this is an indication of this sort of formulaic advantage. What we did is we compared native speakers and non-native speakers. So what we have on the left is English native speakers, and we can see a pretty clear pattern. Again, this consistent advantage. Native speakers respond more quickly to words when they complete idioms than when the words don't. But for non-native speakers, absolutely no effects whatsoever. So I should say this was a group of sort of medium proficiency non-native speakers. And this seems to be a sort of fairly consistent finding. The papers I've mentioned at the bottom here, Carrol and Conklin, that's the study that this is from, but also Cieslicko, who's done this with Polish L2 speakers. Sianowa Chanturia and colleagues did this with mixed non-natives. And we seem to see this sort of lack of an effect, lack of a formulaic advantage for language learners. And Cieslicko has described this as literal salience. And what she means by that is that the literal meaning of these combinations remains the more salient for learners, because they tend to learn words individually. We tend to learn words, or in a second language at least, learn words and then learn how to combine them. Therefore, it's always kind of the individual word meanings that stay more salient. And this is one of the reasons we think we don't necessarily see this effect. Similarly, for people who've looked at non-idiomatic formulaic sequences, we see it, and certainly in English, we see evidence of fast processing of these formulaic sequences relative to non-formulaic controls. For non-native speakers, it depends largely on proficiency. So lower proficiency people tend to, or learners tend to show no advantage, but certainly there's some evidence that if we start doing these same kinds of studies with higher proficiency learners, then we do start to see this advantage. So Sonbul did this with eye tracking. Bilstad and Walter used a similar sort of lexical decision task, or a phrase decision task, actually, I think. Vilkaiter and Schmidt, again, used eye tracking. And all of these showed that when we do these kind of studies with advanced non-natives, then we start to see them moving towards native speakers in terms of how they process formulaic sequences. So this is a combination of idioms and collocations. These studies all looked at collocations. Anna Sianova, in a different study to the one on the previous page, showed the same for binomials. So native speakers process binomials more quickly. Non-native speakers, once they get up to high levels of proficiency, start to show the same kinds of patterns. So, answer to our first question, how do first and second language users process formulaic language? Well, they process it quickly, and this is taken as evidence that there's some kind of representation for this. It's easy to recognize, it's easy to understand. And in terms of second language users, this is something that builds up through experience, and as proficiency increases, they tend to develop this same kind of advantage, but it only really emerges at higher levels of proficiency. Our second question then. How do L1 and L2 interact during processing? So we've said that L2 users don't necessarily show this advantage, but how is that L1 being used here? Is it having any kind of an effect? And the idea really is that language learners, as I've sort of touched on, need to learn formulaic expressions through exposure. You know, you learn words in a second language, you need to then be exposed to the patterns of how these words are used in order to get an idea of how they go together. The point is that no one's starting from scratch here. People are always bringing their own knowledge from the L1 about how words go together and about how they pattern, okay? And the question is, how much does this knowledge influence processing in the second language? So I'm going to quickly talk you through a series of studies that think about how L1 knowledge influences real-time processing. So again, when people are comprehending language, when they're reading language, how is that L1 knowledge coming into play when they read in the L2? So what we did is we took idioms that exist in other languages and we translated these into English. And the question is then how language learners, and specifically people who speak those L1s, respond to them in their L2. And these are 3 studies that I did, 2 with Chinese speakers, so Chinese L1, English L2, and 1 with Swedish speakers. And the point to remember here is that the Swedish speakers were much higher in terms of proficiency. So the Chinese speakers were, I guess, sort of moderate to advanced. Swedish were very much an advanced group. And the kind of idioms I'm talking about are things like this. So this is a Swedish idiom. It certainly doesn't exist in English. So if you've never heard it before, then you know, no need to panic. In fact, very appropriately, the idiom actually means there's nothing to worry about. Okay, you could say this to English people, and they would never have heard it before, and they probably wouldn't know what it means. So this is the kind of idiom I mean when we've translated it into English to see how Swedish speakers might respond to this. This is an example from Chinese: draw a snake and add feet. And again, you might be able to kind of work out what this means. It means to sort of ruin something by adding unnecessary detail. So in this example, you draw a fantastic picture and you keep on adding detail. You're never quite happy, and in the end you ruin something. Again, no one in English would know this phrase. So if you don't recognize it, then don't worry, but it certainly is a phrase that you would recognize if you saw it in Chinese, if you spoke Chinese. So what happens with these kind of examples? Well, this is the second half of the data from that first study that I showed you a second ago, from the lexical decision study. We saw that when we compared on the edge of your seat to the edge of your plate, native speakers show the advantage, non-natives don't. This is the same task, but with translated idioms like draw a snake and add feet. And this time round, English native speakers show no difference. So the native speakers this time are not doing anything, but our Chinese speakers, remember they're seeing the idioms in English. They don't exist in English, but they're still showing an advantage, and a very fast advantage in terms of how quickly it's manifesting. It's giving them an advantage in terms of this lexical decision task, even though the idiom is being presented in the wrong language, if you like. So our first finding is that we seem to have this idiom effect even across languages, and we replicated this using eye tracking in a later study. So we're fairly confident that it's we then apply this to the Swedish speakers. So this is similar data, but for our Swedish speakers. This time it was a reading study. So this is very similar to the first reading study that I talked about. We showed people a sentence with an idiom in it or with a control phrase in it. And we did this with English idioms and with Swedish idioms. And as you can see on this figure, we have our set of English L1 speakers on the left. And on the right-hand side, we have a set of Swedish native speakers who are reading in their L2, which is English. And again, we have a really nice clear-cut pattern here. If English people, native speakers read English idioms, they read them more quickly. And we already know this, we've already seen this. We have this consistent advantage. And I'll just point out, this is the total reading times you can see at the top there. So this is the, if you like, the sort of reading and understanding that we're looking at. But when English native speakers see examples like no cow on the ice, that will be the blue bar, then actually we have a significant disadvantage. So if you read an idiom that you've never heard before, actually you have to spend quite a lot of time trying to figure out what it means. And that's reflected in how long you spend reading it. So a nice sort of complementary pattern here. When we look at our Swedish speakers, though, we see a very, very different pattern. The first thing to say is that the English idioms, well, we're certainly not seeing a disadvantage here. If you compare the English idioms here to the Swedish idioms for the English L1 group, that would be sort of the complementary thing. We might expect, if you're seeing idioms in your second language and you don't know them, we might expect a disadvantage, but we're not seeing that. If anything, we are seeing a slight advantage, and it's not significant, but it's certainly suggesting that the Swedish speakers had very little difficulty processing and understanding the English idioms. They didn't do it quickly like native speakers do, but they certainly didn't have any difficulty here. But what's interesting is this final bar, the one on the far right, where we see an advantage. So when Swedish people are reading in English, and they see a combination of words that they recognize from their L1, then again, we see this really clear speed advantage, faster processing, faster understanding. And again, it bears repeating, despite the fact that they've never read this phrase in English before. No one has seen no cow on the ice in English because it just doesn't exist. So these Swedish people are automatically using their L1 knowledge to help them when they process this. So this seems to, again, be our conclusion. L1 and L2 interaction, well, it seems to be happening very quickly. Speakers are using their L1 knowledge quickly and automatically during processing in their second language. We've seen plenty of evidence elsewhere in the literature that this is true for what we call congruent idioms, so idioms that are the same in both languages. Deborah Titone and colleagues did this in Montreal with French-English bilinguals. Pritchett and co did this with Russian idioms, and both show this sort of significant advantage when idioms exist in both languages. I should say we actually did the same in the Swedish study. We had congruent idioms in there as well, and they were just the same for Swedish speakers as ones that existed in the L1. And similarly for collocations, these three studies rather, all looked at the same question, but with collocations. So taking collocations that either exist in both languages. In the case of Yamashita and Yang, this was Japanese. In the case of Walter and Gilstad, this was Swedish. So when a collocation exists both in the L1 and in the L2, speakers are faster to process them, faster to understand them than for things they've just learned in their L2. So really clear evidence that this L1 knowledge is being used quickly and automatically, I think. I'm just going to show you some very quick figures from another study just to kind of make this point. And I think we sort of keep coming back to the idea that knowledge and familiarity seem to be the main drivers of this. You know, whether this is in your first language or it's in your second language, this doesn't seem to matter. And this was a study where we simply asked people to rate a series of phrases. We gave them English idioms, we gave them metaphors, which are not formulaic, they're not sort of fixed, but they're still figurative. And we gave them idioms that we translated from various languages, and then a subset of idioms that were translated from Chinese. And you can see along the bottom those four categories: idioms, metaphors, translated idioms, and Chinese idioms. And we did this with three groups of people. The first were native speakers of English on the left. The second were general non-natives. And the third were Chinese speakers who were learning English. And all I want to point out here is this is an indication of how familiar all of our speakers found our phrases. On the far left, you can see, as you would expect, native speakers were very familiar with English idioms, much less familiar with everything else. But on the far right, our Chinese speakers, they said they were familiar with all of these Chinese idioms, even though we put them in English, even though in theory, you know, they don't exist in English. They still indicated that they were highly familiar with these. So familiarity, really important here, and it doesn't seem to matter what language that's in. This is the same group of people and the same group of items, but you can see on the left-hand side, this is how many times people got the meaning correct. So when I gave the participants an idiom and asked them to identify what it means, how often did they get them correct? And again, on the far left, we can see that English native speakers, overwhelmingly over 90%, got their idioms correct and identified the meaning of metaphors, but were much worse for translated idioms. And again, the Chinese speakers, well, what we see is that they were much better than anyone else, English native speakers or general non-natives, in identifying the meaning of Chinese idioms that we showed them in English. So again, if you're familiar with these, this seems to contribute to how well you can understand them, how well you can explain them. Again, just to make the same point, this is two charts just showing the influence of both familiarity and transparency on how well people could identify the correct meaning. Pretty clear on the left. The English native speakers, familiarity is really helpful. As familiarity goes up, so does the amount of idioms they identify correctly. Familiarity is less important for the non-native speakers and less for the Chinese speakers, and that's probably a proficiency issue more than anything. And we can see on the right-hand side, actually transparency, relatively unimportant, but for the Chinese speakers, this seems to be sort of just starting to slope upwards. So maybe this is telling us that as familiarity goes down, then transparency starts to become more important. So when you don't know a phrase, then whether or not it's transparent is going to be an important factor. This is the same, but for the Chinese idioms. And again, on the left, we can see that familiarity, very unimportant for our L1 English and our L2 English, but seems to be important for our Chinese speakers. And the trade-off here is that when familiarity doesn't matter, transparency seems to. And we can compare the L1 Chinese on both of these. Familiarity is important, and therefore transparency less so. And I thought it would just be interesting to kind of make the point here that when we compare something that's not formulaic, so we have idioms here that are entirely formulaic, and it's all about whether or not you are familiar with them. In comparison, when we look at metaphors, metaphors are figurative phrases that are not formulaic, where we can see for all of our groups, familiarity having absolutely no effect. It all depends on how transparent these phrases are. So people are having to actively work out what these phrases mean because they have less familiarity with the form. So there's very much this trade-off between whether you know a phrase, in which case you can simply recognize the meaning. And if you don't know a phrase, having to work harder based on factors like transparency to try and work out what it means. So how do L1 and L2 interact during processing? Well, it turns out that they do interact in a fairly major way, and they do interact in a fairly sort of automatic way. And I think we have sort of fairly clear evidence of this now. And I'm just going to sort of finish today's talk by considering this question. How do language users learn new formulaic sequences? So we've seen lots about sort of established sequences, things that we know are common in the language. But what about when people encounter new combinations? And the question really is how much exposure is required to a combination of words before we start to sort of think of it of being a formulaic pattern. So how quickly do we acquire formulaic patterns? And the answer is actually this happens very quickly indeed. And I'll show you some data that helps us to understand this. So this is a very recent study, and this is a study to understand how native speakers acquire patterns when they're reading. So this is an important part of this. We were just asking people to read short stories. So it's a very natural task. And we're interested in how well people can sort of extract patterns from this fairly natural input. So we asked people to read short stories that we'd written with binomials that we put throughout the text. And some of these were formulaic. So tea and coffee, which, as I've said, is highly sort of formulaic in English compared to coffee and tea. And some of these were not formulaic. So these were word combinations that we made up based on the fact that we didn't think they were formulaic in English. And we can prove that there's a difference here, because if we go to a corpus, and this is based on the BNC, the British National Corpus, this shows us that tea and coffee occurs 133 times compared to coffee and tea occurring only 19 times. So that's almost 7 times as often in the formulaic for tea and coffee. And if we compare that for wires and pipes and wires, well, each of these occurs 3 times. So neither of these is a frequent phrase, and neither of them has a preferred word order. So our question really is, firstly, what do people do with these binomials? And secondly, can we sort of make people learn these over the course of reading these short stories? So all of our formulaic phrases appeared once in each form. So we showed them tea and coffee once in the story, and then later on in the story we showed them coffee and tea, so we could compare the reading for the two. And our novel phrases, we showed them varying numbers of times. So some they only saw once, some they saw twice, some they saw 3 times, 4 times, 5 times, and so on. And then they had the same thing reversed. So you might read the story and see wires and pipes, and then 2 pages later see wires and pipes, and then again and again, and so on. And then towards the end of the story, they'd see pipes and wires. So our question is, does seeing this phrase multiple times lead to any sort of formulaic effects? So again, we're doing an eye tracking study, and we're interested in early and late measures. So our first pass reading for these phrases and our later total reading. We're interested in comparing patterns for our attested binomials. So those things that are formulaic in the corpus versus things that we've invented. And I'm actually not going to say too much about that, because the effects are entirely as we would expect them to be. So based on everything I've said so far, we expect an advantage for formulaic phrases, and that is exactly what we see. People read tea and coffee more quickly than coffee and tea. People show no difference between wires and pipes if they see it once compared to pipes and wires when they later see it in the study. So first off, this formulaic advantage that we expect. And it also proves that the ones we've invented are not formulaic. If you see them once, they're not special. But the second question is, what's the effect of repetition? And really, how many repetitions is necessary before these phrases start to be recognized as formulaic? And I'm just going to show you the eye tracking results here and just sort of talk you through what these show us. So on the left, we have first pass reading time. On the right, we have total reading time. And you can see fairly similar patterns for both. And I will just point out that there's fairly big error bars on these graphs. And this is really a result of the way we designed the study. So as I said, we had some items that people saw once, some twice, and so on. What this means is for the first iteration of these, people saw 25 items. They then went on to see 20 of those items a second time, 15 of them a third time, 10 of them a fourth time, and 5 of them a fifth time. And that's why for especially number 5 on these charts, the error bars are very big, because people aren't seeing as many items. I don't think that invalidates our pattern, but it does sort of explain something here. When we then have the reverse, people are seeing all 25 items in the reversed form. Okay, and we can see again a pretty clear-cut pattern. People have shorter reading times as they see each of these phrases more often, and we can show that a bit more clearly here. For each of these two charts, on the left you have the forward pattern. So if you see something more often, we have this sloping effect, whereby seeing something more often means that over time you get faster at reading it, which is really nice. And this is the same for the total reading time. So this seems to be a sort of fairly consistent effect, both in terms of recognizing the phrase and in terms of processing the meaning. But the really interesting thing here is it's not just an effect on the forward form. What this line here is showing us is an upward slope. And this is saying that if you see a phrase more often in the forward form, so if you see wires and pipes, wires and pipes, wires and pipes, and so on, then actually this starts to slow you down when you see the reversed form. So if you've seen a phrase 5 times, it becomes a little bit harder to process the reversed form, because you're expecting the forward form so strongly. So we're seeing a sort of double effect here. It's not just that you speed up as you see the phrase more often, it's that leads you to then not expect the reversed form more strongly. And I think that's, again, a really important point to make. So what do we see? Well, the advantage in terms of both recognition and meaning seems to emerge after really only very few encounters, seeing a phrase 3 or 4 times, and we start to see this advantage. Another important thing to remember is there's not really any difference in meaning here. Wires and pipes, pipes and wires, they mean exactly the same thing. They're literal phrases. So all this is evidence of statistical preference that's emerging very, very quickly. And clear evidence, really, that these patterns continue to be noticed as a part of language processing. And what I mean by that is these are things that we're doing as adults throughout our lives. You know, we're picking up on these statistical patterns. And I'll sort of point you to some recent work by Adele Goldberg, who I'm sure some of you will have heard of, in terms of constructions. And she's got a really similar perspective on this, that it's not just about what we do here, but also about the negative evidence of what we don't hear in terms of how we start to sort of make sense of how language works. So do have a look at some of Goldberg's work if you're interested in this. So how do language users learn new formulaic sequences? Well, it seems they do it very, very naturally from the input and very quickly from the input. And I think that's really, really interesting. So a quick conclusion, and I won't spend too long on this, but the question is, why does any of this matter? What does all of this tell us? And I think what it tells us, firstly, is that formulaic language forms a very important part of native speaker competence. And this is one of the reasons that so much attention is paid to it, because using formulaic sequences, learning formulaic sequences is a really sort of important thing to do as a language learner for a number of reasons. Firstly, you know, from a sort of cultural point of view, I guess a sort of societal point of view, using formulaic language is a way of fitting in. It's a way of sort of all using similar sort of combinations of words and therefore sounding like a native speaker. And this may be more important to some people than others, but certainly it's held up as one good reason for teaching formulaic language. It also contributes to faster processing of word combinations. And again, it's thought that this indicates some level of representation, but this fast processing is all about efficiency. It's about your brain having to work less hard, not having to process everything word by word. And I really like the way that this has been expressed by Alison Ray. And if you do any reading at all about formulaic language, then you'll come across the name Alison Ray very quickly. She more or less invented this as a research field. But Alison described this as a linguistic solution to a non-linguistic problem. And I really like this because it fits in very neatly with a broadly cognitive view of language. And what I mean by that is seeing language not as particularly a sort of special thing, but really as just a way of applying our cognitive abilities in a very specialized way. You know, Chomsky, I said before, he sees language as words and rules, or at least traditionally that was the Chomskyan view, and also saw language as this sort of special human quality. Cognitive linguistics sees it quite differently. Language isn't special, it just happens to be something we can do because we're highly intelligent. So the non-linguistic bit, I think, is important there. But it's a linguistic solution, and I'll just sort of read out this quotation because I just want to pick out three really key parts of it. Alison Ray said, humans, being psychologically and socially complex, are unable fully to meet their emotional, mental and physical needs without involving others. One effective tool for drawing others into behaviours beneficial to us is to employ word strings that are in current use in our community. They enable us socially to align ourselves with others. I am like you because I talk like you, so you'll want to help me. And as a way of minimizing the risk of misunderstanding, since word strings or partly lexicalized frames that have their own semantic entry require less decoding. There's three key parts to this. They enable us socially to align ourselves with others. So it's this fitting in. You know, we all use the same collocations, so we all feel like we're talking the same language in every sort of sense. So it's a really important social tool. It's a way of minimizing the risk of misunderstanding. Idioms are a great example. You know, if you use an idiom or you use a collocation, you know, we all understand, or native speakers all agree what that means on. If I make up my own way of expressing a metaphorical or figurative thing, I run the risk that someone won't understand what I've meant. But if I use an idiom, no problem. We all agree what they mean. And this last bit, I guess, is the most obviously psycholinguistic claim. Word strings or partly lexicalized frames that have their own semantic entry require less decoding. Quite simply, we're going into the lexicon and we're recognizing or retrieving something that tells us how to understand this combination of words. And a nice way, I think, to think about this and to finish is to try and think about what the mental lexicon might look like. And a sort of basic understanding of this is to think in terms of words. Words are combinations of form and meaning. So we have phonological form here, we have orthographic form, and we have the semantic meaning that's associated with a word like this. And we have decades of work that shows us that there are very clear semantic links within the lexicon. Semantic activation, spreading activation, you know, we know this is true. We know that words are organized according to their meaning. We know that words are also organized according to their phonology, according to shared phonological features. But what the data is starting to show us is that words are also organized according to their formulaic combinations. We know that words prime collocations, prime typical partners. So if you look in a corpus, these are the most frequent words that follow kick the ball, kick the cats. These would be collocations. These would be based on frequency alone, but they would be collocations of the word kick. And we have some knowledge of that as part of our lexicon. We have idioms. We know that the kick is part of these idioms. And this is the type of formulaic language, I guess, where it's easiest to see this claim about things being stored as whole phrases in the lexicon. Maybe that makes sense for some of these examples for idioms. But we also have things like phrasal verbs. You know, kick is part of other phrasal verbs like kick off or kick back. Kick back meaning relax. I'm going to kick back and enjoy a beer or something like that. And it only makes sense if you know the meaning of the whole thing. But it's certainly linked to this word kick in our mental lexicon. And then we have other examples, what are called frames or schemas sometimes. And these are semi-filled. They're not fixed. They're not certain combinations of words. You have slots that you can fill. So if you kick someone's arse, in English, you beat them up, you attack them. Same way you can kick something out of someone, and generally it's a rude word or a swear word in the slot there. But these are phrases that people would know, and they have some fixed parts and some not. But they have to exist in our mental lexicon somewhere to explain the kind of data that we've seen. So the point really is understanding how formulaic language is represented in this way helps us to see this is a really multifaceted thing. It's not simply a case of retrieving frequent phrases. This is possibly true for some examples. Some particularly fixed, opaque phrases, examples like kick the bucket, well, it sort of must be represented as a phrase because we can't break it down. We can't understand it any other way. But for lots of other examples, there's some degree of parallel processing. We know this. We know that when we process idioms, we're partly processing the whole phrase. We're partly processing the individual words. When we're processing collocations, we're processing words and the whole thing at the same time. And as I've mentioned, other information, really important here. The semantics, things like mutual information that I've touched on. All of this is important. And it comes back to sort of the conclusion that I would make, which is that we have to acknowledge how complex all of this is, and importantly, how dynamic it is. None of this is fixed. We're constantly learning new formulaic phrases because we're constantly being exposed to patterns of language. So this is constantly changing in small and big ways throughout our lives. So I'll leave that there. I've introduced lots of things, so I'd be very interested to hear if people do have questions, and I'd be happy to answer them. I'll just say thank you to some of the people I've done some of these studies with: Kathy Conklin, who's in Nottingham in the UK, Jeanette Littlemore, who works at Birmingham with me, my good friend Henrik Gilstad, who's based in Sweden, in Lund, who helped with the Swedish study, and Margaret Dowens, who's in China and helped us out with some data collection there. So thanks very much for listening. I'll pop the references on as well in case anyone's interested, and I'll look forward to your questions.
Thank you very much for your delightful and inspiring talk, Gareth. So you gave us lots of food for thought. So there are various questions here and comments, right? So, and I'll read them to you. Okay.
Right. Can I stop sharing my screen, Danny? Would that be? Have you stopped that?
Okay.
No, that's fine.
Yeah.
Okay.
That's fine. Okay. Right. Good. So let me see here. So can I start with the questions?
Yes, please do.
Okay, so the first question is from Juliana do Amaral. Okay, so she asks, Professor Gareth, how would frequency and or familiarity with the formulaic language items interact with processing?
Yeah, well, I mean, I think if there's one conclusion from all of my work, it's that frequency, familiarity, I think we can think about them in the same way, is probably the most important aspect of how we process this. If we know a phrase and we've encountered it many, many, many times, we simply recognize that phrase. I think with idioms, it's the case that we're using our familiarity to retrieve that meaning in some way. And when we talk about this interacting, I think it's not so much interacting with processing, it's driving processing. Other factors then come into play to interact with familiarity. So as I showed with the one of the slides, transparency and familiarity seem to trade off against one another, and they interact in the sense that when you're familiar with something, you don't need, transparency doesn't matter. So I think it's a really good question because it highlights the absolute central importance of this. I've in the last 2 or 3 years absolutely come around to this, that familiarity drives processing, but that's also a problem because it hides lots of other interesting things that are going on. And that's one of the reasons I've carried on with these translated idioms. You remove familiarity and then you can start to ask some different questions because people no longer are simply familiar with them. I will just say one more thing, the difference between familiarity and frequency. You know, in a way, frequency is sort of aggregate familiarity. So familiarity is personal. It's my personal knowledge of an idiom. Frequency in a corpus sort of shows me everyone's familiarity with an idiom, or at least gives me a sense. If something occurs very often, that's telling me that people are likely to be familiar with it, but they're not exactly the same thing. And I think we need to remember that.
Oh, thank you. Yeah, great. So next one is from João Luis Coelho. He asks, Professor Gareth, you mentioned that you see language as words and rules, which I assume that is in the line of to Steven Pinker's view of language, right? Mm-hmm. Having that in mind, how would Formulaic fit in the dual processing model using procedural and declarative memory? And he continues, having that in mind, how would formulaic language fit in the dual processing model using procedural and declarative memory? Oh, it's the same.
So, first of all, I don't see language as words and rules. I used that in the first place to kind of make the point that I think that's the traditional way of thinking of language. I would call myself much more a cognitive linguist, and I think cognitive linguists think in terms of constructions, which I mentioned when I talked about Adele Goldberg and her work. And constructions are a really flexible way of thinking about words, phrases, because they are simply units of meaning. They are pairings of form and meaning. And when we think about this, we can accommodate words, we can accommodate longer phrases, we can accommodate these semi-filled things, we can accommodate grammatical patterns. So words and rules is a useful way of sort of thinking about grammar, thinking about some aspects. I don't think it actually particularly explains some of our data very well. Having said that, in terms of dual processing, actually, this is often how we explain this idiom advantage, that we are doing two things. We are simultaneously processing a phrase and processing a combination of words. And this advantage that we see is often thought of as evidence that retrieving the phrase is faster than processing things word by word. So from the point of view of memory, we're very much saying, well, phrases at some point after a certain level of familiarity are being sort of passed into long-term memory, declarative memory, whatever we want to call it. And it's becoming much more implicit. It's becoming much more about, I guess, rather than procedural and declarative memory, think in terms of semantic memory. Those things are being passed into semantic memory where they can be retrieved, rather than having to be sort of passed word by word. So I would think more in terms of, say, semantic memory and maybe working memory rather than procedural and declarative, but maybe there's a parallel there. But importantly, I think either way, we can account for this advantage. Either it's the fact that phrases as well as words can live in the lexicon, and we can retrieve those phrases, and that's faster than grammatically combining things, or we think in terms of constructions, in which case we don't need to divide words and phrases. They're all the same. They are units of meaning or lexical units, whatever you want to call them, that we've seen before, and we've seen often enough that they are registered and recognized in semantic memory. At that point, frequency effects operate just as they do with single words, and they are easy to retrieve. The more frequent, the more familiar they are. I think that's a really good question, and I think that's how I would think of it. Does that answer it, do you think, Danny?
Yeah, I think so. Yes, great. Thank you very much. So the next one is from Pietra Cassol Higachi. She asks, Professor Carrol, do studies on processing of formulaic language suggest better strategies for teaching collocations, binomials, and idioms?
It's a really good question. I think they do. I think they suggest, if I think about the studies I've talked about today, what it suggests is that people already know quite a lot of formulaic phrases in a second language. So a sort of fairly obvious thing to do in a classroom might be to start by pointing out quite how many idioms or collocations are the same in the two languages, because immediately a learner then has a sort of set of phrases that they can work with, and which will give all of these sort of processing advantages as well. Having said that, how you make that list or how you sort of decide which ones are to include is different. So I would say that it maybe gives us some indication. The second part of that is to think, well, we need to be aware that it's not just frequency, it's not just familiarity. So it's not just a case of learning lists of collocations, for example. And I mentioned that things like transparency interact with familiarity. We've seen in some of the studies I mentioned that this is absolutely the case. So I mentioned one study, Gilstad and Walter, who looked at congruent collocations for Swedish learners of English. And in general, advanced learners processed congruent collocations, they processed L2 collocations quickly, but they struggled when those collocations became less transparent. So they compared what they call free combinations, which are more or less literal combinations of words, like write a letter, very literal, with the kind of more idiomatic collocations, so something like break a promise. And what they found is that learners struggled more with those less transparent ones. So again, maybe what we can take from that is that if you're wanting to teach collocations, you probably don't need to teach them the literal ones, because they're really easy. If you know the words, you know the collocation. you need to spend time teaching the ones that are less transparent, because then you need to do something to either work out what they mean, or perhaps teach things like underlying metaphors that might help you to work these out. So if you're a teacher, that would be my advice, is spend time on the more problematic cases, because that's the ones learners can't work out for themselves. And again, I think the data probably shows us this. Familiarity, transparency do interact, and it's sort of important to think about the two.
Yeah, that's right. So thank you. The next one is from Fernanda Alves. She asks also about the study about idioms, binomials and collocations. If we were to conduct a similar study, but using spoken language instead, would the results be similar?
It's a good question. All of my work has been done with written language, and I think that is a bit of a limitation. I think we, and I include me in that, make the assumption that this would be the same for spoken language. We also make the assumption that the results we have for comprehension would probably be the same as for production, and I don't think that's necessarily true. Certainly there have been studies that have looked at cross-modal priming, and again, I guess a lot of you will know what that is, but cross-modal priming, you hear a spoken sentence before we then present the word on the screen for a lexical decision. And again, we see the same effect. So when people process idioms, process collocations orally, as in they process the spoken version, we still see that advantage. So I think there's good reason to think that this is a comprehension issue. This is recognition of form, and whether that's auditory or whether it's visual, that seems to hold up. Excuse me. Whether that holds for production, I guess, is a different question, and it's not quite the question that was asked. I'll say one final thing, and that's when we look at eye tracking and we look at reading, one of the things we're doing is we are processing the words that are coming up partly in our paraphobia. So I mentioned sort of the corner of your eye. So what we're able to do is recognize sort of the general shape of a word. So when we're processing an idiom, for example, if I can see something that looks like bucket out of the corner of my eye when I'm processing the word kick, that's possibly why I'm skipping over it and why it's more predictable. When you're processing speech, you don't have that, but you probably have the information coming that much more quickly. So there will be differences here. There's not as much work done with speech as there is with reading here. So if you're suggesting doing that study yourself, then I'd say absolutely, please do. I'd be very, very interested to hear the results.
Okay, thank you. So next one is from Professor Maria Cristina Fonseca. So do you happen to know how long children acquire formulaic language? I mean, what steps are there? How old are they when they can use it proficiently?
Another really, really good question. And I think this is an area that is very under-researched. We just don't know how children acquire formulaic phrases. And it's a good question because they obviously do to a very consistent degree. When I do my studies with students, they're university students, they're generally 18, 19, 20 years old. And most people all know the same idioms. So they must have acquired them at some point before that age. But when they come across them, how they encounter them, we just don't know. So I honestly don't know the answer to this question. There's been one or two studies that have looked at how children understand idioms, the age at which they start to understand that idioms have a figurative meaning. Seems to be sort of around 7, maybe. Children are getting, at least some sense of recognizing some idioms. But I think if we're talking about this whole range of collocations, of binomials, it's building up huge amounts of language knowledge over a prolonged period of time. And again, it's sort of language acquisition in general, that the exposure that you get as a child to your L1 vastly outweighs, the exposure that most people will have as a language learner later in life. So, this partly explains why non-natives struggle to acquire these patterns, because children have been exposed to them their entire lives. And I think I sort of touched on this again when I mentioned Adele Goldberg and when I mentioned the binomial study. It's not just what children are hearing, it's the negative evidence, it's what they're not hearing that's helping to kind of put these patterns in place. Again, none of this answers the question. The answer to your question is I genuinely don't know, but I think there's a need to do more work to try and work out, ages at which children acquire formulaic language. We have a good idea of the age at which children have a vocabulary of 100 words, say. There's not really any reason why we couldn't do studies to try and work out, in terms of the most common collocations or the most common idioms, what age children seem to have a vocabulary of 50 collocations, say. So again, if you're thinking of doing work on that, please do. I think we need it in the field.
Yeah, great. Thank you. So the next question is from Pietra Carrol Rigatti. Oh no, sorry, excuse me. So there is another one from Professor Maria Cristina Fonseca. In the case of native speakers, for formulaic language in context, do they skip some of its components when reading?
Yes, yeah. So again, the skipping is the really interesting thing, because we tend to see word skipping for function words, for very short words. And again, if you think back to the video I showed, did that work, by the way? Could you see the dot moving around?
Yes, it worked perfectly.
Oh, sorry if it would work. But what that shows is people are skipping quite a few words, but they tend to be function words. They tend to be very short words. From the eye tracking literature in general, we know that when it comes to content words, they tend to be skipped when they're much more predictable. The data I've collected, and this has been the case in, I think, 3 or 4 studies now, for idioms, skipping of that final word is something like 30% of the time. So around about 1/3 of the time, people are skipping that final word altogether. And that's really high for a content word. But it's showing that these are highly predictable. Once you are reading that first word, you're either getting a very good expectation of what's coming next, or your parafoveal processing is helping you, or whatever it is. But we're seeing really clear evidence of word skipping, and if it's not skipped, faster reading in general. When it comes to things like binomials, we originally planned to analyze the binomial data by looking at word 1 and word 3, and we threw out the data for and because people skip the conjunction 60-70% of the time. People never fixate on that. So again, there's no need to, and I guess it's showing us that the binomials are so fixed in terms of the general form that you don't need to read the word and you know it's there. So again, it's a really good question, because I think the skipping behavior is so automatic here that it's really strong evidence for this formulaic advantage. It's not just faster reading, it's genuinely not even having to read a word fully or fully fixate it. And I think that's, if anything, if we want to make this claim about sort of whole form representation for idioms, this is a piece of evidence I think is very strongly in favor of that, because I'm not quite sure how else to account for it.
Okay, yeah. So thank you. So next one is from Pietra Carrol Rigatti. Professor, how implicit and explicit learning are related to formulaic language? Is formulaic language learned more efficiently in an implicit manner?
Again, I think this is something we have some data on. The binomial study, the last study I mentioned, suggests that we are implicitly picking these patterns out of the input. Again, all we asked people to do was read stories. Maybe they started picking up on the patterns, maybe they didn't, but implicitly they were speeding up as they saw these things more often. So I think related to the earlier question about children, it seems obvious that children must be implicitly learning these. People don't teach children idioms, people don't teach children collocations, yet they have a very consistent knowledge of how these words go together. So I think implicit learning in the L1 for children is certainly the way this is done, and this seems to have a very clear effect in terms of building up that vocabulary. In terms of language learning, I think we are immediately talking about a different challenge. We know this. If you're trying to learn a language as an older speaker, sort of past the age of 15, 16. You know, we all know about critical periods in language learning, and that, you know, maybe it's not as clear cut as some of the data suggests, but in terms of formulaic language, you're probably past the point where you can pick this stuff up implicitly in a really effortless way. So then the explicit learning has to be more a part of it, but there's so much of it, so many collocations, so many idioms. How do you explicitly learn all of these things? So I think people certainly can learn formulaic language implicitly, but it's very effortful. I think the data seems to show us that this takes many repetitions. We've sort of seen some evidence for native speakers. There's a study that I know by someone called Ana Pelice Sanchez, who again has done work on formulaic language, has done work on reading, and has looked at reading in the L2 to see how people learn new vocabulary, just a single word vocabulary implicitly. And even then it takes people 8, 9, 10 repetitions before they recognize and learn the meaning of a word. Whether that's going to be different for formulaic phrases, I don't know, but there's not really a reason to think so. So I would say if you can do it, implicit learning is better, but that is going to be much more, require much more exposure, masses of exposure for that to be useful, and to cover the wide range of phrases that we're thinking about here. Inevitably, and I guess it goes back to the question about teaching, it's probably a combination of the two. If you're picking some of this stuff up implicitly, but also paying more attention to it and then explicitly learning some of these combinations, then that's probably a better approach. But it's another area that I don't think we have enough data on. There's some studies of second language acquisition of collocations, but again, more work to be done, I think.
Yeah, sure. So next one is from Sydney Werner Wolfer. So Professor, could we say that formulaic sentences are consolidated as chunks in declarative memory, independent schemas, thus speeding up processing?
Yeah, and I think that's certainly the way that people have thought about this for the last 10 or 15 years, that this idea of chunking is absolutely what we think is happening here, that these things exist as chunks in memory. And again, we can talk about this as declarative memory or semantic memory, but you know, it's there in the sort of long-term storage. And the reason I prefer to think in terms of semantic memory is it's a bit more sort of specifically linguistic in a sense, but declarative memory works just as well in terms of what we're trying to say here, that things are being genuinely registered as whole sequences in memory to some degree. And the point is that is not the same as they are simply unanalyzed. They're not long words, which is what was proposed in some of the very early studies, because we know they're being retrieved and being analyzed at the same time. So we had the earlier question about this dual processing. We are retrieving a chunk and at the same time analyzing it word by word. This just happens to be faster and happens to give us the meaning of the whole phrase. So I think absolutely this is what's happening. To kind of relate this to the other questions about L1 children and learning, we're almost kind of suggesting that children learn formulaic language by being exposed to the chunks and then learning to break it down. Whereas if you're learning in your L2, you're going the other way. You're learning words, then learning to combine them. And maybe this is the real difference here, that children get exposed to all these patterns. You know, they don't really, they repeat phrases, they repeat chunks of words, and only later on learn that they're made up of component parts. So maybe that's the real difference here, is they're chunks to start with for children, and then they get broken down. Whereas you have to actively learn to combine them as an adult, and that's a much more effortful process. And implicitly, if you learn a language, you don't want to just learn a chunk. You don't want to learn what a section of speech means without breaking it down into its component words. It's not how we learn as sort of cognitively mature people. So absolutely, thinking about this in terms of chunking, in terms of declarative memory or semantic memory or whatever we want to say, is a really important part of this. The danger is that we make it a little too simple and say that we're just dealing with chunks here. I think we are, but we're also dealing with things that we're analysing, that are competing with other things in the lexicon, and that sort of constantly there's all these variables happening at the same time.
Oh, thank you, thank you. So the next one is from Pedro Ricardo Bin. Dr. Carrol, do you think formulaic expressions are processed as lexical unit or through syntactic rules?
So I think it's the same issue, it's the same question. I think both is true, and these dual root models seem to suggest that we're doing both. And one of the sort of really important pieces of evidence for the fact that we're doing both is the fact that idioms compete in terms of their figurative and their literal meanings. So I mentioned literal plausibility at one point. There's lots of studies now that show idioms that are more plausible, i.e. that can be literal phrases, are processed differently to ones that are not literal at all. So what this is saying is that the literal meaning, which is word by word, it by definition has to be words and rules, is competing with the figurative meaning of the whole phrase. One of the really interesting sort of lines of evidence here is people who've had strokes or brain injury, maybe have aphasia or dementia or other conditions. And one of the things they seem to really struggle with is inhibiting the literal meaning of idioms. So I think this is definitely showing us there is this dual process going on, that we are accessing the figurative meaning of a whole phrase, the chunk, if you like, and we are using our grammatical knowledge to combine words one by one into a literal meaning. And most of the time, we're very capable of inhibiting that literal side of things if the context tells us that's appropriate. What we see in people with certain language impairments or certain brain injuries or cognitive impairments is a real struggle to inhibit that side of it, a real struggle to ignore the literal, if you like. And it's often taken as being an issue with executive control, so the brain's ability to sort of manipulate this information. And I think all of this evidence comes together to support what people are saying in these questions, which is that yes, we have these chunks, yes, we have these phrases in our lexicon. It's not just a case of retrieving them, because at the same time, we are analysing things because it could be literal. If I see an idiom, someone could literally be kicking the bucket. So simply retrieving that phrase as an idiom doesn't help me out if I don't have access to the literal meaning, which can only come from that combination of grammatical units, if you like. So I think we're sort of saying, I feel like I'm saying the same thing for a lot of these answers, but they're really sort of useful questions to get that point across, I think.
Sure. Thank you. So the last question, right? Professor, it's from Lane Coutinho. So, Professor, how do translators process formulaic expressions? And do you think that learning formulaic expression, idioms, for example, is a good way for non-native speakers to learn more about the culture?
Definitely. Two parts to that question. The first, how do translators do this? I don't know. I don't have a huge amount of experience of translation or working with translators. So it would be really interesting to sort of speak to translators and get a sense of their understanding of formulaic language, whether they're particularly aware of these patterns. I think in the case of things like idioms, they must be, because when you encounter idioms, translators, the aim is not simply to translate things word to word, it's to translate the sense of it. And obviously the challenge there is to find not just an equivalent meaning, but an equivalent idiom with the same sort of pragmatic meaning as well. So I think translators must be aware of some of this, and that must have an effect on how they process and understand this, if only because they'll be at such a high level of proficiency and awareness. The second part of the question, the cultural side of it, absolutely. I think idioms are so rooted in the culture of any given country that they can at least sort of help to give a sense of some of the things that may be more important for certain cultures than others. So in English, we have lots of idioms related to sport, lots related to cricket, for one thing, a very sort of typically English sport, related to sports like horse racing, boxing, and lots of idioms related to ships and seafaring, which I think sort of reflects the sort of past of the British Empire and that kind of thing, sailing around the world. In German, there's lots of idioms that revolve around pigs and sausages and that kind of thing, because pig farming has been such a really central part of German culture for so many years. So I think that the point is, again, if people are trying to learn idioms, there's potentially a lot of value here, but there are so many idioms that it's hard to know which are the kind of important ones to learn, which ones might be more relevant, more appropriate. The danger, of course, is learning a meaning without learning how to use that phrase. And again, it's the pragmatic aspect of this. And I think, I can think of examples from just conversations I've had with people where non-native speakers who have absolutely flawless English in so many ways, misuse an idiom in a way that a native speaker never would. And it's almost impossible to explain what they've done wrong. It just isn't quite right. And again, it might be that they've used it in slightly the wrong context, or they've used it in a slightly in a grammatical way that they can't. So I think it's tempting to say, learn idioms. It's a great way to become more native-like. Not that that's necessarily the aim, but to certainly from the point of view of learning more about culture, I think this could be a very sort of fruitful thing. I think it's a part of all of this that we don't really talk about in psycholinguistics, but it must have an effect. I think the cultural relevance, the cultural values of idioms sort of must come into this, because we can't just treat language as divorced from everything else that happens in our heads and our memories and what have you.
Yeah, that I couldn't agree more with you. So there are other questions, but unfortunately we have to finish, right? And this was a very good and thought-provoking, stimulating talk. So please, Gareth, your final words to the audience.
Final words. I feel like I've made the main point several times, but the last thing I said in the talk is important. I think it's tempting to think of formulaic language in terms of chunks, in terms of things that are in memory, things that we're retrieving. The data is showing us that it's just more complex than that. There's so many other variables to take into account. Yes, we are to some degree retrieving something from our semantic memory. Yes, we're to some degree recognizing a form that we've seen before. And this explains this sort of fast processing. But we need to be aware how dynamic this is more than anything else. It changes because we're constantly being exposed to language. Therefore, everyone, native speakers, non-native speakers, we're constantly in sort of very minor ways restructuring our language over time. And I think if as linguists, as experimental psycholinguists, we need to be really aware of the range of variables that are potentially important here, and to sort of bring these into our studies if we're going to learn more about this.
So again, I'd like to thank you, Dr. Gareth Carrol, for accepting the invitation to talk to us today. And I'd like to thank the audience for their questions. Thank you very much. And see you next week, October 1st, for the next seminar. So goodbye.
Thank you very much. And thank you for the questions, genuinely interesting and thought-provoking questions. So thank you for listening.